System Introduction in Case 1. In the first case study, we explore whether there are any local factors that impact the pricing of Airbnb rentals in Chicago. The price per person is selected as a dependent variable. The rental values near the downtown area are higher. Then the independent variables are selected by observing the VIF values and annotations for the features in the original feature list. The analyst first selects the number of Airbnb spots, number of crimes, and the Airbnb host rating. The analyst explores the correlations among the income per capita, unemployed, and poverty. Strong linear correlations are observed among these features in the scatter matrix. Since the income per capita has a linear relationship with the dependent variable, especially around the downtown area according to the scatter plot and the bivariate map, the analysts choose income per capita as the fourth independent variable. The analyst presses Train Model button and is taken to the model analysis interface. Once the model has been trained, the expert observes the model's global and local performance to determine whether the dependent variable has been well explained by the model by validating the spatial distribution, the numerical distribution, and the textual explanation of the local R-square. The analyst finds that the model performs better in northern Chicago. The analysts update the information description to northern Chicago to enhance the communication and understanding. The Cook's distance indicates 5 community areas as potential outliers in the model. When checking the standardized residuals, the analyst finds no systematic pattern of over or under predictions in the study area according to the spatial distribution which has been measured by Moran's eye. The explanation shows the model's performance is acceptable. The analyst adds the narrative explanation as well as the histogram and the box plot of the local residuals to the report authoring panel as the explored findings. Next, the analyst explores how each independent variable influences the Airbnb prices. The host's rating and crime number have partial positive influences to the price, while the income per capita has a positive influence over Chicago. The central portions of Chicago show the strongest influence of income per capita. The analyst selects the central regions on the map to explore the relevant external context information in the external key phrases list. The analyst notices the selected regions include Chicago downtown and the Chicago Loop is an influential phrase. By exploring the original Wikipedia paragraph list, the analyst identifies the Loop as a popular tourist and business area. The analyst captures the explanation of the spatial distribution with the corresponding map snapshot of the income per capita into the report authoring panel as the explored knowledge. The map's color scheme can also be changed. Finally, she polishes the report by adding the learned context information and exports it as a PDF file which can be shared with others. Please find the generated PDF files in the supplementary materials. In the second case, we demonstrate how GeoExplainer can be used in collaborative research. 2 domain experts work together to analyze the 2016 U.S. presidential election data. The first expert configures an MGWR model on GeoExplainer with a similar model configuration process that has been demonstrated in the first case. After being satisfied with the configuration, the first expert saves it and shares the trained state file with the second expert who is interested in exploring the modeling results. Here we present how the second expert assesses the extent to which the local contextual effects may have influenced the outcome of the election through GeoExplainer. When browsing model coefficients, the expert notices an unusual spatial distribution of the percentage of the younger voters. The expert gets insights from the narrative explanations and finds the system has automatically detected 4 clusters that has a significant positive inclination for young voters to vote Democrat. The expert locates the first cluster in Ohio, browsed the external key phrases. He notices Ohio University is one of the high-ranking phrases. After browsing the original Wikipedia contents, the expert knows Athens County of Ohio is home to Ohio University. He searches the key phrases of Athens County and realizes it is a Democratic stronghold. Then the expert records this finding by adding the relevant contextual information and narrative model explanation to the report authoring panel. A snapshot of the corresponding cluster is taken and dragged to the report panel as well. In this case, the local intercept coefficients indicates the intrinsic support for Democratic Party or the Republican Party if all counties had exactly the same mix of population. The analyst selects the intercept and explores the spatial distribution of the local intercept coefficients in the choropleth map. The spatial distribution shows the counties throughout New England, the upper Midwest, and down the Pacific coast intrinsically tend to vote Democrat, and counties throughout the South except for Florida intrinsically more likely to vote Republican. The analyst then adds explanation and a snapshot image to the report panel to generate a PDF report.